continuous delivery is a set of principles and practices that improve the stability and speed of your release process. I'm sure everyone here knows that. But what does it actually mean to be doing continuous delivery? Do you need to be doing 3 deploys a week, 3 deploys a day, 3 deploys a minute? You know, why aren't you deploying right now? The answer is it depends, which I know is a really lame consultant answer, but there is actually some truth in it. So I always say that you're practicing continuous delivery when the stability and speed of your release process is good enough to satisfy business demand. If you don't have that, if stability and speed are insufficient, then you are in a state of discontinuous delivery. Now, discontinuous delivery is something that I invented. I have a trademark pending. Please don't steal it. I went on thesaurus.com and looked at antonyms. So, how do we actually adopt continuous delivery? Well, if you look in the book, the holy book, or if you look in Dave and Jez's book, that is not any other holy book, and subsequent literature over the past 10 years or so, then you'll find a whole list of technology and organizational changes that you need. So here's a list of technology changes that I cooked up for you lovely people at my kitchen table. Let's pick up one of these. So database migrations. Who here works in a company where database migrations are fully automated? I don't. Nobody. Wow. Okay. So database migrations, very difficult problem to solve, very risky problem to solve. But think about the value in that, okay? Think about if you had that, the improvements that you would find in stability and speed. Now multiply that by all of these other changes, okay? You probably need all of them, all right? And that's complicated further by the smorgasbord of tools that are out there, right? So the good news is, I hope the sponsors can't hear me, the good news is that it doesn't actually matter which tools you use, okay? As long as you avoid the really, really bad ones, you're going to be fine. It doesn't actually matter if you use Chef or Puppet or Ansible or Terraform or the other one, okay? Just don't use WebSphere. All right, anyone here from IBM? Of course not, they never come to see me. All right, so why would they? Okay, so here's a list of organizational changes, okay? And yes, these are more valuable, and yes, they are more challenging than the technology changes that I just shoved up on screen. Okay, so let's take out one of these again. So everyone doing on-call. Who here works in a company where everybody does on-call? Product owners, business analysts, testers, get the phone call at 3 in the morning to say the site is down. One person, thank you. My current client doesn't, and we're actually about to move to that model. There's some contract work pending on that. So again, think of the cost of doing that work, right? Think of the risk involved, the contractual changes, maybe some union negotiations, maybe some people are quite sad at the thought of being woken up. But think of the value in that, okay? Think about the value of everyone feeling the same shared responsibility for their product. Okay? Now again, multiply that by all of this stuff. All right? Now, the bad news is this is not the thing that's challenging about continuous delivery. It's not this amount of work, okay? The challenge is how to apply these changes to the unique circumstances and constraints of your organization, okay? Your organization is like no other. It's a complex adaptive system in which each individual has partial information and the cause and effect of an event can only be perceived in retrospect, okay? So then the question is, how do we adopt continuous delivery? And the answer is that we need to continuously improve stability and speed until we can satisfy business demand. So how do we do continuous improvement? The best way we have is with the Improvement Kata. So I'm sure some people here are familiar with it. It's by a guy called Mike Rover from his work studying Toyota over the years. With the Improvement Kata, we create some established practices around your existing ways of working in your company. And the way it works is you repeatedly cycle through the same 4 steps to accomplish particular improvements. So step 1, you understand your direction. You need to create a vision of success that will inspire people and give the people a sense of urgency. Step 2 is you need to understand your current condition. You need to understand how far you've gone towards your goal. That means assessing your quantitative and qualitative data. And step 3, you need to create a target condition. That's an improvement milestone on the pathway towards your goal. You attach to that some success criteria and a time horizon, and then you iterate towards that target condition until you reach success or you run out of time. And the way that you experiment is you run different experiments in parallel. So you might try to do shared on-call as well as automated database migrations in parallel. And you try them with the plan, do, check, act cycle, which is by Dr. Deming. So I've reached my mean time to a reference to Dr. Deming in 6 minutes. Dan North will be very proud of me. I know he's always watching. Okay, so the way that we actually then improve, the way we understand if we're improving, is that we need to measure our adoption of continuous delivery. And I'm sure everyone here heard Nicole's great keynote earlier. So as she mentioned very modestly, far too modestly, Nicole and Jez have done some really great work with their colleagues on understanding what makes IT successful in organizations and how organizations benefit from that. As well as their State of DevOps reports, they've also done their peer-reviewed research that shows that throughput and stability improve in unison, when you actually put the effort in. So for years, I know that big IT companies have been saying to you that you have to choose between stability or speed. I'm afraid they've been lying to you all these years because they want your money, and they want to wallow in your money in their bathtub. I'm sorry to be the one to break that news to you. Okay, so the measures that Nicole spoke about earlier, that's what's important, right? So we have stability framed in failure rate and failure recovery time, and throughput framed in lead time and frequency. These pairs of measurements form clarification chains. That means that they take something that's intangible, like stability or throughput, and they make it tangible. They make it possible for us to measure them. So a measure is a quantification, a value of a thing at a single point in time. Okay? So that has some new information. But if you repeatedly measure something over a period of time, then you get metrics, right? And then you can understand improvements or regressions over time, and you can maybe pin those to particular changes that you've made. I like to go a step beyond that. I like to take my metrics and apply the same temporal properties to them and put them into a single visualization. So in the case of stability or throughput, I like to do these measurement pairs together and then show them in a single graph afterwards, and I call those indicators. And what those give you is an understanding of emergent trends in a domain, and it suggests where you need to find new information. Okay, so 4 years ago now, I had the idea, after reading some of Nicole and Jez's work, to create deployment indicators, to apply these indicators to production deployments. So we'd have a deployment stability indicator from failure rate and failure recovery time for deployments, and a throughput indicator for deployments from deployment lead time and deployment interval. Now, you need these measurement pairs because one on their own is simply not good enough, okay? You might have a deployment lead time, for example, of 1 day, and you can prance around Copenhagen saying how lovely that is if you want. But if you're only deploying to production every 3 months, then you're going to be incurring some significant opportunity cost. Also, with the exception of failure rate, which is a percentage, in the case of failure recovery time, lead time, and interval, we can measure the average and the variation, and by doing that, we can understand if an improvement or a regression is consistent and predictable or just a flash in the pan. Okay, so this is what our deployment stability indicator looks like. This is just a generic technology value stream. Code goes into version control, it goes on the branch if you really must. You build it on a build server, you deploy it to production, and it goes bang. And that's when we get our deployment failure rate. That's the percentage of all deployments that incur some kind of failure. And then we have deployment failure recovery time, which is the median and standard deviation in time between the start and end of all production failures. Okay, and we have deployment throughput. Deployment throughput is deployment lead time. That's the time from a artifact being built and it being deployed into production. And deployment interval is the median and standard deviation in time between production deployments. Now, for those of you that were paying attention in Nicole's talk earlier, you will have noticed that Nicole and I define lead time differently. She talked about the time from code commit to production, and that's definitely the traditional way of looking at it. I look at deployment lead time just from your build server to production, and I'll explain why that is in a little while. Now, don't be fooled by that little arrow there, okay? That little deployment interval arrow, all right? That's where you're losing all your time, okay? You can get in a fancy continuous delivery consultant from London if you really want to do some value stream mappings with you on your lead time from build to production. And yes, you're losing some time in handover delays and in technology, but the real time losses, they occur in the interval between production deployments, okay? We'll come back to that later. Okay, so I have actually implemented this. Between 2014 and 2017, I was an operations team lead in a major UK government department. It's responsible for over 2/3 of all transactions with the UK government online. And my team was responsible for delivery enablement and release engineering for 60 teams. And those 60 teams were responsible for 100 digital services online, and they were composed of around 500 microservices running on a secure multi-cloud platform as a service. Okay, so at a single note, we've been able to get rid of that whole "this won't work at scale" thing, which always depresses me. That's good to get that out of the way. So my team was there to help our 60 teams to deliver faster, and I wanted to help those teams to adopt continuous delivery. This is the value stream for this government department. Happily, it's very simple. Code goes to version control, code goes to a build server. There was an optional end-to-end testing environment if you really had to do end-to-end testing. Please don't do end-to-end testing, at least don't tell me about it if you are. There was a mandatory performance testing environment, and then you went into production. All of the functional testing happened locally, which was awesome. One less environment you have to worry about. Now, of our 60 teams, all had the same release process, all had these same environments, and all the teams were cross-functional, which means there were no handover delays between teams, no chucking over the wall to test or operations or whatever. So that gives us an interesting problem, which is the more obvious constraints to continuous delivery are not in place in this government department. But when we started out, we simply didn't know what our teams were up to. We didn't know which teams were performing well, which teams weren't. And more to the point, which team do you help first? Do you help the team in London that's, sat opposite you waving to you like, "Hello, Steve, please help us"? Do you help the team in the north of England, that, have been screaming for help for a week? Do you help the team in Fishguard? That is a place, they're responsible for guarding all of the fish in Britain. And, we haven't heard from them for a year. What are they doing? They're coding on a branch somewhere. We can't seem to stop them, Steve. But there's a real problem here, right? How do you know which teams to help before they know they need help? All right? And the answer is, obviously, we need to measure their release process. We need to measure the stability and speed of their releases. So the way we did that was we created a vision of success. That's very easy in the UK government. You wait till lunchtime on a Friday when everyone's out, and then you write a compliments page and say, "This is what we're going to try." Don't do that. You should get some business people to do it. Don't do what I did. It needs more business context. I suggested that everyone should deploy with fewer than 5% failures, and if you have a failure, you should recover from it in under a day. And for deployments, we suggested that teams should deploy to production at least once a fortnight, and it should take them less than a week. Okay? Now, this might seem really ambitious to you, this might seem very conservative to you, but remember, it depends, okay? This was something that was quite ambitious for us across 60 teams, okay? Anyone that says you have to be doing 3 deploys a day to be doing continuous delivery is a little bit misinformed. Okay, so this was our deployment stability indicator, okay? And we had some surprises. We had some teams that had a deployment failure rate of 0%, and a deployment failure recovery time of 0 days, which is great, okay? But a majority of our teams had a deployment failure rate of 10%, and their average failure recovery time was 5 days. So 1 in 10 production deployments fails, and it takes you a business week to fully remediate the problem. That's not great. So straight away, this new information helped us pinpoint the teams that needed our help the most. We found one team that had a deployment failure rate of 67%. They were kind of getting a bit reluctant to actually deploy. So they were the first team that we looked to help. Okay, so that's what the value stream looks like. This is what an indicator looks like. So this is a deployment stability indicator for, we'll call them the Apples team. I have to disguise who they are because the government is searching for me. And also because the Apples team were very good and got quite big heads when they found out that they were good. Okay, so the way this works, on the x-axis we have time. I've chosen an arbitrary 6-month period for you nice people. The left y-axis we have deployment failure rate as a percentage, and the right y-axis we have deployment failure recovery time in days. We need to have 2 y-axes because they have different units of measure, and that's as far as my maths can go. All right, so how does it work? We've got a blue line showing deployment failure rate, and we can see for this team that it's improved from 20% to 0% in over 6 months. in under 6 months, I should say. And their deployment failure recovery time, the dark red line, improved from 9 days to 0 in under 6 months. Okay, so we want these lines to trend downwards towards continuous delivery. If you are thinking that the lines need to go up, then we have a problem. So this team clearly has improved in a really significant fashion, right? They were having a failure, once in every 5 deployments, and it took them nearly 2 business weeks to respond, and now it's absolutely nothing. Okay? Now, we simply didn't know this. This was a team based very, very near to us in London, and when we went to meet them, they were kind of, getting on with it. I think they were up to like 4 deploys a day, and they were like, we just do it, Steve, it's no big deal. And we tried to understand why they had had this improvement in stability. And the only thing we could spot was that their monitoring dashboards were better than everyone else's. They had had someone on the team who was really into the logging and metric dashboard tooling that we used, and they had created some custom dashboards. So we exported the JSON, we created a DSL in Python, I think, or was it Scala? Probably Scala. And we generated the same dashboards for all of our 500 microservices, and we shoved it into production in a day and a half, I think. And straight away we saw a really big improvement in people's notion of responsibility for production and people's awareness of the operating conditions of their services. We wouldn't have had that tool if we hadn't had that insight, and that insight came from this indicator and this team, who weren't even aware themselves how well they were doing. All right, so with deployment throughput, we had a small number of teams that were deploying to production once every 5 days and in under a day. And that included the Apple's team. So as Nicole said earlier, when stability improves, throughput improves as well, and vice versa. But again, we had a majority of teams where they were deploying to production once every 21 days, and it took them 12 days to do it. So that's beyond our vision of success. That's a lot of teams that need our help. We had one team that had a deployment lead time of 3 months and no deployment interval. Can anyone tell me what that means? Okay, a stunned silence. All right, so that means they did 1 deploy ever. It took them 3 months to go through 2 environments. That's enough, Steve. No more deployments. We're fine now. We're good. Bless. Okay, so this is a deployment throughput indicator for the Bananas team. On the left y-axis, we have days, and that's for deployment lead time in orange and deployment lead time in green. And we can see that variation is declining, the lighter colors, but the dark green line is a concern here, right? Their deployment interval has regressed from 3 days to 14 days. So this team was doing well, but then they started to go in the other direction. And I think we caught wind of this around April time when it was just starting to go in the wrong direction. And we had all kinds of theories on what might have caused this problem. They're doing too much end-to-end testing, they're doing some end-to-end testing, different kinds of tools, fluctuating business requirements, and none of those were right. And there's an important lesson here, okay? That you can't understand reality from a few data points. There's something called the Ludic fallacy, which is when you try to tell a story from a limited number of quantitative data points. Okay, an indicator doesn't tell you what the stories are. It tells you where to go and find the stories, and they are the things that give you that valuable new information. So we went to meet with the team and sat down with them, and very quickly I realized the problem. I didn't know many of them. The entire team had left to join some trendy startup down the road that lasted a few months, so good for them. And this new team, they were new to one another, new to the platform, new to the service, and they simply couldn't sustain 1 deploy every 3 days. That's a contextual, useful piece of information. That's nothing wrong with that at all. Okay, so it occurred to me quite a while ago now that the measures that Jez, Nicole, and friends use can be used for things other than deployments. We can reapply them to different aspects of the technology value stream. So I had the idea of creating build indicators, continuous delivery mandates that your code base is always in a releasable state, that you're always pumping out a high number of high-quality builds. So for build stability, we have build failure rate and build failure recovery time. And for build throughput, we have build lead time and build interval. Okay? And we're expecting a positive correlation between a high build throughput and a high deployment throughput, and the same for stability. Okay, so this is what our indicator looks like. Build failure rate is the percentage of builds that fail on our build server. And build failure recovery time is the amount of time, the median and standard deviation in time between the start and end of all build failures. Build throughput is the median and standard deviation in time between a mainline commit and a build on the build server being successful. And build interval is the time between builds being created. So I mentioned earlier about having a narrower definition of deployment lead time. That's because I like to measure build lead time separately to understand correlations and trends between the two. Okay, so I had a vision of success for builds, which was that build failure rate would be less than 1%. Build failures would be recovered in under an hour. Builds would be created in under an hour from when they were kicked off to when they finish. And your build interval would be at least once a day. Okay, so nothing too ambitious there. So we found some interesting things with this. We found that we again had we had a small number of teams where their build stability was really good, their failure rate was 0%, their recovery time was under an hour. But a majority of teams had an average build failure rate of 19% and their recovery time was 4 hours. We actually found one team where their average build failure recovery time was 12 days. You know, when I phoned them, they were just like, "We've been waiting for you to phone us, Steve. We knew you'd find us." You know, and I had 60 teams to lose, like a needle in a haystack. And 12 days. You know, the build's red. What should we do? Let's go on holiday for a while. Someone else will fix it for us. All right. So here, don't do that. So build stability indicator. This is the grapes team. So the left y-axis is build failure rate. The right y-axis is build failure recovery time in hours. So the dark purple line here is build failure rate. And you can see it's very low, which is great. But the build failure recovery time, that dark blue line, that is near static at 10 hours over 6 months. Now, as I said earlier, you can't predict things accurately in a complex adaptive system, but we can have some heuristics. And if you have a time-based metric and it's near constant over 6 months, especially when it's a high number, then there's probably a human meddling with something somewhere. You know, it's a stochastic word out there that doesn't feel right. So I had a chat with I think I stumbled on this one by accident. I had a chat with the tech lead in question, and it turned out that their acceptance test took 10 hours to run. So their solution was to build before the acceptance tests ran, and if they failed, then they would go back and run them again. So they had no incentive to improve those acceptance tests because they didn't feel that it was on their critical path. So we helped the team understand that this was a risk they were carrying down into the value stream that they really shouldn't. We parachuted someone into the team, not literally, the government doesn't let you do that, I tried. We sent someone into the team to help them out with their acceptance tests, to strip out all of those rubbish UI acceptance tests and create some really nice API acceptance tests and some better unit tests. I think a few weeks after this, we managed to get it down to about an hour's build, which was like a really, really great accomplishment. Okay, so build throughput. We found that all of our teams, all 60 teams, averaged less than an hour from a commit to master and a successful build, which was fantastic. But there was a huge discrepancy in build interval. Remember what I said earlier about those little arrows, those interval durations being the interesting ones. We had a small number of teams that built every 2 hours, but the majority were building once every 2 days. So there's a lot of teams there that clearly need our help with their builds and with their code. So this is the build throughput indicator for the oranges team. This was quite a delicate situation. So the left y-axis, we have hours for both build lead time in yellow and build interval in red. So build lead time is near constant at 0 hours. That's fine. We've already seen that all of our 60 teams were doing that. But the red line is interesting, okay? So in January, they were building once every 4 days, and in only a month, they improved to building once a day. And then they gradually regressed to 4 days. Now, I don't have enough time today to play with audience expectations, which is a shame because I like to do that. But that's too fast, okay? I know I want everyone to do continuous delivery because that will make everyone much happier. And that will make me happy. But it's too fast. It's very, very rare that a team is going to improve that fast, okay? In my book, I call this too fast, too frequent, okay? In my experience, when a team improves that rapidly in builds or deployments, number one, someone's got a gun to their head, again, metaphorically, people in the British government don't have guns. But it means that the team's under pressure. And this was exactly the case. We went to speak with the product owner very politely, and we found out that there'd been a significant business event, and the team had been asked to build more frequently, to do more testing, to do more deployments. And we showed this particular indicator to the product owner, and we had a second indicator, which was their stability indicator, which showed that as they went much faster, stability suffered, which was a really interesting correlation to see. So we worked with the team after this to gradually improve again. We worked on their acceptance tests. We worked on the way that they structured their code base. And we saw, after this time, we saw a gradual, sustained improvement on their part. Okay, so final indicator. So, continuous delivery practitioners for years have experienced, seen, acknowledged the fact that if you are coding frequently on master, if you are building frequently, then you will have the opportunity to deploy frequently. So continuous integration is a really key enabler of continuous delivery. Continuous integration is not a tool. Please stop saying that it is. Continuous integration is a practice where every member of your team commits to master or trunk or mainline, whatever you want to call it, at least once a day. Okay? When you are coding on master frequently, you have the opportunity to build frequently, and you have the opportunity to deploy frequently. And the best way we have of doing continuous integration is to do trunk-based development. You could also do something like GitHub Flow if you want to, with really short-lived branches, but trunk-based development is best. So stability measures can't really be used here because your version control system isn't going to cough up information on failed commits. You know, that's reserved for your local working copy. But we can look at code throughput. We can look at the mainline commit lead time and the mainline commit interval. We can look at how long it takes you to go from a branch commit to a master commit. And we can look at how often you're committing to master. If you're using something like trunk-based development, then your mainline commit lead time is clearly going to be 0, and we can be friends. You know, that would be great. Mainline commit interval is the median and standard deviation in time again between master commits. So our vision of success for this is really easy. It's not like continuous delivery. It's not a dynamic threshold based on business context. Continuous integration has a definition, so we can say simply that your mainline commit lead time needs to be less than an hour, and your mainline commit interval needs to be once every 24 hours. That's actually pretty conservative for a large team. So we've had some pretty shocking numbers here. We had some really interesting learnings. All of our teams had an average time between branch and master of 0 hours, which was really positive. That was really good to see. But there was some really, really significant variation there, as you can expect. We'll come to that in a moment. But the average time between mainline commits was the interesting one. We had a handful of teams out of 60 that were committing to master at least once every 2 hours, and included the Apples team I mentioned way back at the start. Okay? But a huge majority of our teams, their average mainline commit interval was 5 days. Okay? We found a strong positive correlation between teams that were committing to master frequently, building frequently, and deploying frequently, as you know, we would expect given Nicole and Jez's work and people's experience in the continuous delivery community. Okay, so here is our code throughput example. This is the Pears team. I have been unable to eat any pears since this particular episode. Even the thought of them strikes fear into my heart. So this is a graph with the left y-axis in hours, and the x-axis again is in time. Our dark blue line is the median mainline lead time, the time from branch to master, and it looks like it's 0 hours here, but it's actually creeping up to 34 hours. You can't see that because the y-axis is so huge. Over a 6-month period, this team's mainline commit interval changed from once every 4 days, which is pretty bad, to once every 27 days, which is, you know, pretty bad. Okay? So in a 6-month period, this team went in completely the wrong direction. You know, they went from building once to be able to use the central build server to build branches, when we said that's not really how we do things. That will fetishize branching. That will encourage you to reduce the pain in your build process. they got quite sad about it. There were some pointed emails, and in the end, I actually went to visit this team somewhere else in the UK, and I sat down with the team leader, and we looked at the data together, and we also listened to their experiences, because it's important, as I said, to use this data not as a definitive guide, but to indicate something, and it normally indicates the need for a conversation. So we learned that this team was under an awful lot of pressure. They were being asked to make major architectural changes to their system, and at the same time they had to keep shipping new features. And the only way that they knew to do that was with long-lived branching. And what we did was we spent a bit of time with them. I asked very nicely for a lead developer on another team to spend a few weeks with them. And they gradually found the right seams in their code base to use feature toggles to conceal the architectural changes they were making. And there were some really unexpected benefits to that. Their code base gradually improved, team members became a bit less stressed, but also they had some operational benefits. There was a production incident I only learned about afterwards where a third-party service they used announced on really short notice that it had to go down for emergency maintenance. I think we all know what that meant for emergency maintenance. When that happened, the owners of the Pears service became quite excited for a little while, like, what do we do? This service we depend on is about to go down. Until one member of the team said, can't we just toggle off our call to that service? Can't we just return a dummy response for a while and, degrade our service and stay up, keep saving the taxpayer money? I wasn't actually involved in that. It was really, really great to hear that story, that this team had seen some improvement in resilience as a result of using toggles and moving away from code branching. Okay, so how did we actually do it? So we had a deployment database, and that we automatically recorded data into whenever a deployment happened. We had a build server that stored build data, and we had a version control system that surfaced out information over its API. So I think initially I just wrote a couple of Python scripts in my spare time that sucked the data out, turned them into CSV, and I shoved them in some Google spreadsheets and showed them to people. Okay, that took me about a day, and my Python sucks. Okay? So don't let anyone tell you that this is a really complicated thing to do. As long as you're collecting the data, which is the hard bit, as long as you've automated that, then this is really easy to do. Okay? After that, we gave it to a few developers who turned it into a nice Scala service and ironed out some of the problems. And now it's something that's hosted on an internal website, so all teams can see it. You can look at the indicators for your team or the indicators for your service. There are no comparisons between teams, because that would lead to bad behaviors. There are no comparisons between services. That would also lead to bad behaviors. There's no information captured on individuals, let alone shown about individuals, because we want to emphasize that this is about how a team can improve itself and how a team can judge itself against itself rather than against other people where there might be a different context or different circumstances. So continuous delivery has gained real traction in this government department, which is really good to see. And there have been some real success stories out of it. Measuring continuous delivery didn't tell us what to do, but it did tell us where to go to find out what to do. Okay, we were in a huge amount of uncertainty, trying to deliver an enormous amount of change to the taxpayer with 60 different teams doing 60 different things all the time. And this approach really worked well. I can tell you that this approach will work well with one team, with 6 teams, with 60 teams. Collecting the data is not hard, measuring the data is not hard, and it will bring real benefits to your process of adopting continuous delivery. So let's wrap up. So continuous delivery is hard, continuous delivery is extremely valuable. Those things are only going to increase over time. The best way to adopt continuous delivery is to continuously improve. It's not to try and do loads of things at once. It's to have some kind of discipline about it. Use something like the Improvement Kata. Try different changes in parallel. Understand the direction you're trying to go in, the benefits you want in stability and speed, and then try some stuff out. Okay? And to do that, you need to measure your progress. You need to actually understand which changes are having a positive impact, which changes are having a negative impact. And when you do that, that will give you some really powerful insights into how you can best adopt continuous delivery and how you can make it work for you. Thank you very much.